find p. It's this whole thing. Okay. The first thing we can do is set a variable, because I don't want to work with these actual numbers. Instead, if I set variables, at the end, hopefully we can get a simplified expression and we can solve for p. So I'm going to set a variable x, but which number should we set it to? Let's do 2020, because we have a 2020 squared out here. And if we rewrite that in terms of another number, for example, if x is 2021, this would be a minus 1 squared. That would get really messy. So yeah, that's a good idea. Let's do x is 2020, and now we can rewrite p in terms of x. 2019 would be x minus 1, 2020 is x, times x plus 1 times x plus 2 plus 1. Square root of all that, minus x squared. So now this is a little nicer. Hopefully it's easier for us to work with. Now I'll just expand. I'll do x squared minus x times x squared plus 3x plus 2 plus 1 square root of all that minus x squared. Then we can further expand x to the fourth. This times this is 3x cubed, and then this is minus x cubed, so plus 2x cubed. This is 2x squared minus 3x squared is minus x squared. Then this is minus 2x, and then the plus 1 at the end here. So square root of all that, minus x squared. Well, ultimately, this whole expression here should be a perfect square, so that we can take the square root. And if we look at this first term here, it's x to the fourth. The only two things we can multiply to get that is x times x cubed or x squared. And this is what we want, because we want to rewrite this as a square. We're going to rewrite this as, x squared plus ax. A can be positive or negative. And then we can either have plus 1 squared or minus 1 squared, because at the end, this constant term will both be positive 1. So now we've got two possible forms of perfect squares. We can rewrite that in. And this one won't work because we've got negative coefficients here. And we need this to be negative so we can have negative coefficients. Now we've settled on a form. Now we just need to figure out what a is so we can write the actual perfect square expression. If I expand this out, we can get x to the fourth plus ax cubed plus ax cubed, so plus 2ax cubed. Technically, we can already stop here, and we don't really need to rewrite the rest of the expression, because here we've got 2ax cubed, and here we've got 2x cubed. And since we know this is the form of the expression of the perfect square, 2ax cubed matches up with 2x cubed. Therefore, a equals 1, so 2 times 1 times x cubed is 2x cubed. So if we plug a back into this expression, we should be able to get the perfect square for this. And our root is easier. So p will be x squared plus 1 times x is actually just x minus 1 squared, take square root of all that, minus x squared. Now we are almost done. This square root and this square root can cancel out, and then leaves us with positive x squared plus x minus 1, and then minus x squared at the end. X squared minus x squared is 0, so the p equals x minus 1, and x from the beginning we defined as 2020, so that's 2020 minus 1, p equals 2019. That's the solution, and using this you can also discover that the product of any 4 consecutive integers plus 1, take the square root of all that minus the second integer squared, is always going to be the second integer minus 1. It's really cool. Let me show you. We just found out that p is 2019, which is 2020 minus 1. What if we started with just 1, 2, 3, 4? So 1 times 2 times 3 times 4 plus 1 square root of all that minus the second integer, which is 2 here, 2 squared. 1 times 2 times 3 times 4 is 24, plus 1 is 25. Square root of 25 minus 2 squared is 4, and we know square root of 25 is 5. 5 minus 4 equals 1, and 1 is 1 less than 2, which is squared. Let's try that again with 2, 3, 4, 5. 2 times 3 times 4 times 5 plus 1 square root of all that minus 3 squared. 2 times 3 times 4 times 5 is 120, plus 1 is 121, minus 9. 121, the square root of that is 11. So 11 minus 9 equals 2, which is 3 minus 1. Let's do one more. Let's go for maybe a bigger number. Let's go with 4 times 5 times 6 times 7 plus 1 square root of that minus 5 squared. 4 times 5 is 20, 6 times 7 is 42, that's 840 plus 1 is square root of 841 minus 25, 841. That's going to be 29 squared. This is 29 minus 25 equals 4, which is 1 less than 5. I hope you enjoyed this, and I hope you learned something. You can use this cool trick. The product of any 4 consecutive positive integers plus 1, square root of all that minus the second integer squared is equal to the second integer minus 1, or the first integer.